Hello everyone, my name is Dustin Vance and this is my presentation for General Chemistry 2 Advanced Concepts 8 Kinetic Sand Experiment. The first thing before discussing some of the science behind it is I wanted to show videos of me making the sand. So in this first clip we have some sand that I just acquired from outside. Cornstarch is already mixed in and I am slowly starting to mix in the water and dish soap mixture. The video supplied mentioned multiple times how it's important to add in small amounts so as not to oversaturate the sand. So that's what I'm doing here. I'm just adding gradually smaller and smaller amounts, mixing until we get closer to where we need to go. And you can just see I'm adding more there. And then here momentarily I do stop the video because it was difficult to try to mix the sand and record the video at the same time without spilling it all over the floor. So in this second clip you can see here that I've fully mixed it and we now have our homemade kinetic sand. The sand here when it is wet does not act like this. It is not like beach sand. It is very, very small granules that does not hold together even when it is wet. And when it is wet, it forms more of a slurry or a paste. So this is formable, holds its shape, it kind of flakes off, and the more you press onto it, the more firm it becomes. It does get stuck onto my hand slightly, but I think that was from when I was mixing it rather than when I was interacting with it here. So it did work well. Clearly resembles the kinetic sand you would purchase in store, and I was rather surprised with the results given that this was just performed with sand that I found out in my driveway. So I'm very satisfied with the results from this. And just to go a little bit further and show its ability to form and hold shape, I took one of my son's toys for sand, which is in the shape of a fish, stuffed the kinetic sand into it. I did have a little bit of trouble getting it out of the mold with one hand, but as you can see there, it formed well, no cracks or anything, and a clearly visible fish shape. So it did well in this experiment. And as mentioned in the previous slide of making the sand, it's actually incredibly simple. The components are just sand, cornstarch, water, and dish soap. And it's about finding a balance in not oversaturating the sand with water, not having too much cornstarch, too little sand. If you follow the video, it's quite easy to find a decent balance that will give satisfactory results. So now the question of how does such a simple mix make such a drastic change in the way the sand reacts? And it all relies in the cornstarch primarily and how small its molecules. The sand is mostly just a carrier. It will help as the structure for things, but what is occurring is that as the cornstarch is mixed in and dissolved, the starch remains sort of in suspension. And these incredibly tiny molecules, when they get near each other, they start to have friction and charges. So normally when you try to combine two things, the molecules don't exactly touch. There's those repulsive energies. But in the case of such small molecules such as this, if you apply enough force or pressure, they will contact each other and they form friction. This is why when you squeeze it, it is able to hold shape. It becomes more solid. And this is actually more interesting in a different form of experiment when you think of non-Newtonian fluid or oobleck, which I will discuss in a moment or two. But in the way of kinetic sand, basically in simple terms, the way it functions is that it makes the sand act as if it's wet all the time without drying out or without sticking to other substances. That's kind of where the dish soap part of it comes into, is helping with it sticking to other things and keeping to itself in a sense. As I mentioned, it allows the sand to act as if it is always wet, and the sand that you purchase in store, the actual brand name kinetic sand, uses silicone oil to produce the exact same result. I do have theories that the oil mixture would withstand time longer than the homemade version, as it is likely more stable and will withstand different temperatures and environments more soundly, but the concept in how the store-bought and how this works is the same, and it also reacts to different factors. I already mentioned how pressure makes it more firm, it holds its shape. Also too, it would react to heat, because if it was heated, it would thin the solution, or the mixture, and the sand would be able to flow a little bit more freely. It would eventually dry out and return to its original state. Of course, if you heated it too much, it would eventually start to melt and form glass-like composition. But we are not talking about superheated temperatures, more temperatures that would just cause the water to evaporate in this case. And as I mentioned, if you simply remove the sand in this mixture, you get what's called oobleck, or non-Newtonian fluid, which shows even clearer what I was talking about with the molecular size of the cornstarch. Because in oobleck, if you just let it set at rest, it acts like a liquid. It will fill whatever container, it will form to the shape of it. If you hold it in your hand, it will drip through your fingers, but if you squeeze it hard, it will become solid, it becomes brittle and breaks, and if you take and punch it, it is hard. So that is because you overcome the forces that are allowing it to slide past each other. The tiny molecules are able to slide past each other, but when you apply enough force, it actually makes them collide. And that friction makes the substance become firm and resistant to whatever force you're presenting, such as if you're punching it, it becomes firm and it stops the punch. You could take and slowly dip your finger into the substance and it would just slide right into it. It wouldn't have much resistance at all, because it is gradual pressure versus that it's that strong pressure that overcomes the resistance. So if you overcome that resistance threshold and again the molecules touch, you get friction. If you do gradual and you're not overcoming that pressure threshold, they continue to slide past each other and act much like a liquid. I hope this has been a satisfactory explanation of kinetic sand, how it functions, as well as the little extra deep dive into non-Newtonian fluids and oobleck. I thank you for your time, and I thank you most importantly for taking the time to present this class, and this is my last presentation, and I have enjoyed all of them so far. Thank you very much.